continuing from where we ended. This is example 3. The maximum allowable value of each of the reactions is 180 newtons. Neglecting the weight of the beam, determine the range of the distance d for which the beam is safe. So in this question, we are to determine the range of the distance d given here for which the beam is safe, and we have each reaction to be what? 180 newtons. So the reactions are what? They are given. So let's see how best we can solve this question. First, we have to draw the free body diagram. So we can draw the free body diagram and indicate the relevant what? Forces, external loads on it. So first, my solution and my free body diagram will be this way. So this bar will detect all the fixed point and the rulers. And I'm getting something like that. So let's assume this is the bar. And already I have 150 Newton force here as 150 Newtons. I have another 100 and a 50 Newton force. There's a point A here and point B here. What about the reaction? At A, the reaction is a ruler. It rolls, so a ruler has an upward reaction, which is A in the y direction. And here it is a fixed point, it's a pin, and the pin has two reactions. At B, we have the upward one, and we have the x1, that's the horizontal one. Now we have a free body diagram. We can begin to solve for the relevant distances. It says each of the reaction is 180 Newton. So Bx is 180, By is 180, Ay is also what? 180. The reactions, they are what? Given. So it's left with the dimensions. What is the distance between this and that? D, that's what we are supposed to find. And the distance between this and the 100 Newton force is what? 450 millimeters. And out of that is also 450 millimeters. We can work in meters too so that it will be simple for us. So I'll try to find only D. And since it's an equilibrium question, let me try to take moment. Mostly if you want to take moment about a point that has many of what? The unknown forces or many forces such that they will what? All run to zero. So I'll take moment about B. Remember, if I take moment at B, this 150 Newton force will what? Will not be affected. Or I can take moment about what? A first. In any way, it will be what? Accepted. I'll take moment about A and both B. So first, let me take about what? A, so that you see how we can. Let's forget about the idea that this one will run many of them to a zero. But let me take it at A so that you understand perfectly how moments are what? Taken. So moment at A, summation of moment at A should also be what? Zero. In the other episode, I chose the clockwise direction. This one, I'm choosing the anti-clockwise so that you see how that one also what? Goes. All right, so all forces going anti-clockwise will be what? Zero. So let's start. First, the moment at A. This is at A. So it's only this AY4 that will not be what? Counted. And this BX will also not be counted because it will pass through the moment what? Center. But this 50, this 100, this 150, and this BY will be what? Counted. So let's start. About A, the 50 is going the anti-clockwise direction about A, so it is positive. That is going to give me a positive 50 times. What is the perpendicular distance? From 50 to the moment point is D. All right, so let's take the 100. It's going clockwise, negative. 100 by, what is the distance? From here to there is 45 or 0.45. But there's a subtraction of D here, so it will be, the distance will be 0.45 minus D. Are we good? Let's look at the 150. It's also negative. So 150 by, what is the distance from here to there? The total distance is what? 0.9 or 900 millimeters. But there's a subtraction here. So 0.9 minus what? D for the 150. What about the BY? Because this BX is already 0. So the BY is also going what? Anti-clockwise. Look at about this is going anti-clockwise, so positive. Plus BY, what's the distance? It's also 0.9 minus what? D, because I don't know D and I'm solving for D. They should all run to 0. That's my first equation. So I want to make D the subject from this place. So 50 by this will give me 50D. I'm expanding. And this by that, I'm going to get 45 plus 100D. So I'll have another 150 by 0.9, negative 135 plus 150D. This I'll get plus 0.9 BY minus DBY equal to 0. So grouping all the D's and other stuffs, I'm going to get, so the D's, 50D is here, 100D, 150D. So I'm getting 300D. There's another D, which is by what? This, minus DBY should be equal to. Let me group all the other stuff. I have the others to be moved to the other region, which is the 45 and the 135. It will be 180 here because they will tend to be positive. And I have another 0.9 what? BY minus 0.9 BY. Are we good? So making D the subject, so I'm getting D should be equal to, already I have 180 minus 0.9 BY on 300 minus BY. Remember, BY is a reaction and all the reaction they are what? 180. So putting 180 at where BY is, you see that your D now will be 0.15 meters or 150 millimeters. So for the first point, our D is 0.5 or 150 millimeters. But since the question says determine the range, we have to find another D where the range will what? 4. So we've taken moment about A. Let's take moment at B to see the distance from here to A. We've known that the distance from the end to A is 0.5 or 15. Now what is the distance for which the beam is safe from this point to the B? So moment about B, summation of moment about B should also be 0, the same anti-clockwise direction. So now the moment is here. This 150 will not count, this BY will not count, this BX will not count. So we are left with 1, 2, 3, the 3 forces. The reason these ones are not counting is because they are passing through the moment point. They are the place. If I'm taking moment at A, the force here will not be affected. It will not count. The same thing if I'm taking at B, these 3 forces will not count. They run to 0. So first, let me consider my 50. Since it is anti-clockwise about what? B, it is positive. So 50 by what is the distance? From here to there, 45, 45. Remember, from here to here, 45, 45, or 50, which is 900 or 0.9. To the AY, it is going what? Clockwise about point B, which is negative. So minus AY, the distance is the entire distance minus D. Don't substitute this D, 0.5 here. Okay, let's just move and find another D, which is 0.9 minus D. Then the last force, 100, is also moving what? Clockwise or anti-clockwise about point B. So positive 100, the distance, this is what? 0.45. This should run towards 0. And with this, if I punch, I'm going to get 45 minus 0.9 AY plus D AY, then what? Plus 45, 0. So grouping like terms to find D. My D will be 0.9 AY on 90 by what? AY. And we know that each reaction is 180. So AY is also a reaction, which is what? 180. So putting 180 in, your D will now be what? 0.4 meters or 400 millimeters. So the range for which the beam is safe is now 150 millimeters less than or equal to D, less than or equal to what? 400 millimeters, and we are good to go. So with the moment, it helps us to what? Get our D, and this is the final answer. Example 4. Determine the reactions at A and B. This is the diagram. So first, let's draw a free body diagram. So I can redraw this to obtain my free body diagram. It's simple. So I'm getting my diagram drawn nicely. So I'll indicate all the relevant forces. I have a 50-pound force and I have another 40 here. And the distance between this and that is 4 inch. Initially, I told you the inch moves with what? The pound what? Force. Okay, so what about the reactions? The distance down is 10 what? Inches. The reactions, this is a fixed point. So it is going to have two reactions, an upward AY and a horizontal what? AX. And here too there is a ruler, but it is at an angle. Look at this reaction, it's a ruler. So it is going to have a single what? Perpendicular reaction like this. So, and the angle it makes here is what? 30. So this is the angle. Remember, it makes an angle of what? 30 degrees here. Are we good? All right, so this is the angle 30. And what's the distance between this and that? 20 inches. So this is my free body diagram. And I want to know the reaction. I have what? The reaction. So reaction at what? B. Let me call this B as the reaction. I want to know the reaction. I have three unknowns. So meaning I need all these three equations. F of x should be 0 and F of y should be 0 and moment, summation of moment about a point should be also what? 0. So I need all these three to know all the three unknowns. First, let me start with my moment. And I'll take moment about A. Since A has the majority of the what? Unknown, so that these two forces will go what? 0. Because here is the moment point. So summation of moment about A I'll prefer my anti-clockwise direction again to be positive, so be 0. So first, let me start with this. I'm going to start with the forces. So let's go. So B. Remember, this force should be resolved into what? Both vertical and horizontal what? Component. Are we good? Should be resolved anytime you are dealing with a structure and you have a force inclined at an angle. We don't take the magnitude of the force like that, maybe 20 Newton. We resolve the force. That's why we talked about force what? Resolution in the previous what? Chapters or episode. So this, you have to resolve this to both horizontal and vertical what? Component. And if you resolve this as the hypotenuse on the horizontal component, remember the horizontal component will pass through this moment center and it will be 0. So it will be left with only the vertical what? Component that will work. Are we good? And now to resolve this on this vertical component, the vertical component will be b cos theta, this vertical part. And this horizontal will be b sine theta, because this represents the adjacent and this represents what? The opposite. Are we good? So b, taking the vertical part, multiplying its distance, this b will be b cos theta, which is the theta is what? 30 degrees as the force. Multiplying its distance, 20. Are we good? Since it is an upward force, the reaction is going upward. And about this point, it will go anti-clockwise and it is positive. What about this 50 IB? This 50 IB will move what? Clockwise, negative, which will be 50 times the distance, 4 inches, 4. And lastly, this horizontal one, it will move what? Still anti-clockwise direction, negative. And its magnitude is what? 40 IB, which will be 40. The perpendicular distance from the moment center is what? 10. Multiplying what? 10. The moment should be 0. So to make B the subject from this is mathematics, and we can see that our B will be 34.64 IB. Are we good for the moment? So we got the reaction at B to be 34.64 IB. What about the AX and the AY? I can now take summation of forces on the X to get for the AX. So summation of force on the X to be 0. What are the X component of forces? I have, this is a horizontal force, this is horizontal. I will resolve this both vertical and horizontal. So I have to make what? An impact here. Are we good? All right. So I'll choose those forces going this way to be positive, and those going this direction to be what? Negative. Are we good? So I'll choose, looking at this B force, I resolve the vertical one upwards and the horizontal one, I'll resolve it this way to the left side so that it will oppose this ones to keep this balanced. So I have my AX, there's no moment, so I'm summing forces. AX is positive plus this 40 is also in the positive direction. This B, the horizontal part will be resolved as b sine theta, because looking at this triangle, this is the opposite and it will be minus, it is against the sense this way, negative, b sine 30, and this is equal to 0. Already I know b and I will input b, and my AX now will be negative 22.68 IB. When you punch this, you make AX the subject, you're going to get a negative. Are we good? Meaning the direction I choose for, your answer is not wrong. Someone will get a positive 22. You are all correct, but it means my direction for AX is not correct. It is actually in this direction. I chose it to be looking this way, but the answer is telling me no. The reaction at AX is rather in the other direction. So that's what it means. So you can write your answer as AX is equal to 22.68 and you show the direction. Let's find, so we know AX leaving what? AY. So we can use summation of forces on the Y to find AY. All upward forces will be positive and downward forces will be negative. So AY is positive and this 50 is coming down negative. And the B part, the resolved part of B upward is what? A positive one, which will be B cos 30 equal to 0. Making AY the subject, AY, we know B already. AY is what? 20 IB, positive. Meaning the direction I choose for AY is correct. It is what? Upward. If it was negative, I can say AY is what? Negative 20 IB down. So in all, this is how we look for the reactions in equilibrium. I hope these examples has helped you a lot to understand equilibrium, and you have to try your hands on many examples. Thank you for watching this episode.